In this last video, we are going to discuss how lists are actually implemented in C++. In the previous set of videos, we created our own implementation of list ADTs, but we don't need to do that. Like we teach you that because understanding the implementation, like implementing these structures by yourself, helps you in better conceptualization of how they actually work or in scenarios where you can use them. In this video, we are going to see how lists are actually implemented in C++ STL. So basically, like if you go use this link, which is c++.com, this is actually a great website. I'm going to give you a tour of this website on in Monday's lecture and tell you like how to read it. Basically, it provides you hundreds of functions as well as the data members which are already existing in the STL library. Uh, and if you see like this list ADT, you'll find that in the container section of the library because list is a type of container in C++. Now, how lists are implemented? They are implemented in the form of arrays, in the form of vectors, in the form of list, as well as forward list. There's something also called deck, which we are going to discuss in the queues. It's also like a type of list. You can consider that as a type of list in STL, but we are not. We are going to skip it for now. We are going to discuss in Friday's lecture when we cover queues because it's called a double-ended queue. So, what are the affordances of like these different? Why does C++ offer all these different ways of implementing the list ADT? So there are like pluses and minuses of each approach. Like array has fixed size, while vector is a dynamic array which grows. Like let's say you define the vector with no size. It might have a size of 1 or let's say some constant. Whenever you fill the array or vector up to a certain threshold, the size of it doubles. The next one is list. If you go to the reference like and check it out, you'll see like how they are implemented in STL. You don't have to remember all these functions, but all the common ones like begin, end, remove, and stuff you should know because whenever you are solving problems later on, they come like very handy because they are like very powerful tools, and you don't want to create your own remove or add method again and again, but just use the STL versions. So list actually behind the scenes implemented a doubly linked list, while forward list is something new to C++11. Although C++11 is pretty old, it implements the single linked list and it's just a forward list. So when we talk about list containers, like as I mentioned earlier, like it's just a doubly linked list behind the scenes. If you go to this link again, like there are different functions that are there. I'm going to tell you like how to read this, but let's say in this list API, like I'm just talking about list now, which is it's not the list ADT, but the list or the doubly linked list implementation of the list ADT. So this offers a constructor which takes two parameters n and val, where and this is described in the library as it creates a new list which has a size n with default values val. So in this case, let's say if we are trying to call the statement by list and then like all these lists are templated as well as all the other containers. So if I do list int and my list, and if I do 4 and 100, it will create a list or a doubly linked list of size 4 or has which has 4 nodes, and each of those have values 100, as you can see. Another function is push front. I'm showing this because I cannot show all the functions on the slide and we are not going to go over all the functions, but you're going to use all of this in the STEPIC exercises. I would highly encourage you. There are like 4 questions on STEPIC on linked list. Please do that, and also you're going to learn all these in the future projects. For the first project, you have to implement a templated linked list, which is you cannot use something from the library. That's like forbidden. But for this particular function, push front, this adds a new element at the beginning of the list, which is right below the first element. So it creates a new node with the value val. And in this case, like if I do push front 200, it will, my new list would look something like this: 200, 100, 100, and 100. Now, one question you might be asking is, how do I traverse or print this list out? So all the containers that we are going to discuss, and this is just not specific to the containers or the list ADT, but also to trees, graphs, and stuff. There's something called iterators in C++. And what are iterators? Like, iterators are basically abstractions of moving forward or backward in a data structure, which is, you don't want people to code what is next or back. And iterators support three different operations. The first one, it gives us access to a starting element. Also, it has a pointer to the last element. And finally, it gives us access to the data using the dereference operator or the indirection operator, which is, if you do star IT, this will give you access to what is the value. So I'm going to show you once again, which is how do you define an iterator is you use a container, which is like in this case, we had a list int container. And if you use the scope resolution operator followed with iterator, you can define a new iterator of this type. Like if you want, you can also use like auto. That's absolutely fine if you don't want to memorize this. And what mylist.begin function does, it returns an iterator or a pointer. It's not exactly a pointer, but it gives you an iterator to the first element of the list, which is in this case 200. The list.end function, like mylist.end function, gives you an iterator to the last element. Like all of this is useful because you don't want to deal with all the pointer operations, or you want to abstract the details of how you are traversing in a list. And next, you can increment the iterator by using the plus plus operator, which is from this position, you can go to the next one, and so on. So the condition we are checking is we have not reached uh, the end operation. So basically, you print the values using star IT, which is, although we are getting this iterator, you use the indirection or the dereference operator to print the value at a given instance. Now, all the STL, or like let's say if you're designing your own ADT, which will be a binary search trees, which we are going to discuss in the future, stack, queues, or linked list, you can define your own iterative class, which is you need to overload the iterator class. And I would strongly encourage you to look into that, which is like how we can build our own custom iterators in the future classes. It's very useful concept because we don't want to we just want to give the user access to begin or this end terminology rather than to have access to each of the pointers. So again, like just to sum up, like whenever we are using custom built iterators, if you want, I can create a video on like how to build custom iterators. I'll try to create one stepping problem as well to make sure you understand this concept. But this is an important concept. Again, like this won't be asked to you in the exams, but this is an important concept for the projects. Like let's say if you're implementing your linked list project, which is the templated one, try to build your own like iterator class for that linked list project, which is iterators have operators to advance to the next data. They have the dereference operator, like you need to overload this plus plus operator, this star operator, as well as this not equal to operator, like whenever you are building your custom iterators. And finally, you need to overload the assignment operator because you are assigning this value to the custom iterator. So this is the standard time template libraries iterator. You can build your own iterators for your own classes. I'm again like emphasizing on that. This is a great reading. Like if you want to understand like how to implement iterators, just click on this link and you might be able to see how to add like an iterator class to your own data structure. So since we are out of time, I'm not going to discuss this question on merging two sorted linked lists. We are going to discuss this in Monday's problem solving lecture, because on Friday I want to focus on stacks and queues. Some of the recommended resources, again, like this is a very important resource, which is how to code these different linked lists in C++. There are 4 questions on StepEc. Try to do those. They'll also be helpful for your quiz. Also, like try to read chapter 9.1 to 9.7 if possible, and the templated linked list reading. It's just like 1 or 2 pages. It shouldn't take more than 30 minutes of your time. So try to finish those. That's it for today's videos, and I'll see you guys on Wednesday. Thanks.